Perfect. So now we should be good by now.
Okay,
And
cool.
give me one quick second. Let me make sure it fixes all over the place. And I will go and start with the presentation. One more time, welcome everyone. We are about to get started, okay? Today we have John Miner, and John Miner is our speaker. He's a good friend of mine. Let me make sure I get things done. I do the introductions as fast as I can, okay? This session will be recorded for your information. I would like to remind you about our community. It's fall under two categories. We have what we call Feature Data Driven Summit, which is a yearly conference, which we highly suggest you to go and register. And we have our user group here, okay? And if you would like to speak to our Feature Data Driven, the call for speaker is currently open. We highly suggest you to go and sign up and scan this and submit your session. If you don't have time to scan this, feel free to go to our website, which is datadrivencommunity.com, and submit your session. And also, if you go to call uh, for speaker for data community, we register this here call for speaker as well. You are free to go there and submit your session. If you would like to register and share the registration form with your peers, this is the QR code. You are free to go and scan this and register, right? This event is scheduled to be live on September 24th. I'm pretty sure most of you are aware of this event. It is a well-known event and it is free, where we have about 64 different speakers speaking about data, AI, and visualization. 95% of these sessions are related to Microsoft. So therefore, if you are a Microsoft members, trust me, this event, you don't want to miss that, right? And who we are, let me show you. This event is, this community is being managed by four of us, right? So we have Ronen. He is the primary person. He's the one that taking most of our decisions. We have Anna and Dipti that work very close with Ronen. And myself, I am the founder of this community, and I am the secondary co-admin. So uh, I am a data and AI engineer and work for Microsoft as a technical trainer, where I mainly focus on data and AI. If you would like to connect with me, you are free to do so by scanning this one, okay? And this is the four of us. With that said, even though last weekend was what we call International Women Days, I would like also to, keep the party, the appreciation, love going on, and happy International Women Days to all of you. Yeah. With that said, if you have access to uh, post your question in the chat, feel free to take advantage of this. Once you click on this icon, you have this interface that will be available to you for you to post your question, and John Miner will tell you how should you post your questions. Okay, so if you do post a question and John Miner answer that question, you love it. Those are the icons that will allow you to interact. To access to those, this is where you have to click. With that said, it's a pleasure to have John Miner. We always have John Miner every year, twice, in our weekly webinar and in our yearly summit. I'm pretty sure you probably already submitted session to our feature data driven. So with that said, thank you for sharing your time with us. And John Miner, it's always a pleasure to have you. Thank you for all your support. Feel free to share your screen, okay? Introduce yourself and start with the presentation.
We'll kick it off. Thank you, Gene. Yes, if you have not signed up for Future Data Driven yet, please do. This will be the 4th year that I've talked at, and hopefully second year of being a moderator also. It's a very rewarding time. You get to listen to other people and learn other things while not only presenting, okay? So this is my desktop. Let's pop open uh, Google Chrome and talk about some things. So the very first thing I want to show you is this, is if you Google, again, not enough coffee, too much working going on lately, but if you Google John Miner 3, okay, on GitHub, you'll come up to this repo called Community Work. And I have a bunch of presentations. I've been doing this for 10 plus years. This talk is called Understanding Lakehouse File Formats, okay? What is Lakehouse? Well, Lakehouse can be Databricks. It can also be Fabric. We're going to talk about Fabric today. It can also be anything that's Spark compliant, okay? So anything we talk here about is probably transferable to any Spark, okay, installation, okay? So I'm going to close that. I've been writing for Jeremy, who owns MS SQL Tips with Greg also, and I've been focusing there just on Databricks and other stuff. Okay, hopefully preaching up to 125 articles there. So that's kind of exciting. I'm going to close that, but if you want information, say, on what's Databricks or maybe Databricks streaming, and again, we're talking Spark today, you could just go down and say, hey, yeah, I can look at JSON filements and look at what John talked about streaming, okay? For Fabric, I talked to Steve Jones, who runs SQL Server Central, and I've been writing about Fabric. So for instance, if you want to know why tally tables are important, or basically let's talk about a metadata-driven pipeline for data engineering, there's a lot of cool stuff here, okay? So enough about me. Let's talk about what we're going to do today. When you start with Fabric, okay, we need a capacity. I have an F64 SKU up because I was doing just before this demo. I was doing a demo on Copilot, and to have Copilot work, we have an F64. And once you turn on Copilot, look, you can't scale it anymore, okay? And this is our Fabric one. If we go into the workspace, and I signed in already, we can see I have a bunch of workspaces, and one workspace is called file types, and we're going to go through this today, okay? So with that said, I think I've kind of did the intros, and let's get into the slide deck, and then we'll do some demos in between. Do I have this up twice? That's the question. Yes, I got this one, so I want to make sure I got the right one. Perfect. Okay. Yeah, so I've been in the industry since 1991. Back then, there was no internet. There was no Windows. We had DOS command line. So everything's changed and it's exciting. We've gone from, hey, I have to look at a book that Paul White wrote or something other book, maybe Paul Nelson. And basically now I have to go ahead and understand everything versus now we have Copilot and things we can ask questions about. But this talk is about the file formats, and you should know them because there's only so many file formats. And having which use case and when to use them is really important, okay? There's one thing I did want to turn off, which is I'm going to turn my camera off. I'll turn it back on end, save a little bandwidth because I see it's going a little slow on my part. Okay, so file formats for the Lakehouse. Let's go to the next page. Okay, purpose. So when we talk about Microsoft Fabric, you go to John and you'd say, hey, John, how long's it been around? And it's like, it's relatively new. Like I said, I've been in the industry for almost 40 years coming up. Um, Not that long, like, 35 plus, right? And so if we look at it, it came available in November of 2023, okay? And so how can we leverage it to solve problems? And there's 4 type of problems that it can solve: a lake house, a data warehouse, data science, and real-time analytics, okay? And so today we're going to talk about basically the file formats, right? So it's basically the lake house. Okay. So to give you some background, we need to talk about what's the Spark ecosystem. We need to talk a little about the medallion architecture. We're not going to get into using it, but we're just gonna need to know about it because that's where you want to use a medallion, because it allows you to separate your raw data from your refined, and your refined, which would be, you know, cleaning up stuff or reorganizing stuff, to your gold, which would be ready for reporting. And again, you can call them bronze, silver, and gold. You can also call them raw, refined, and curated. Okay. We'll talk about what's a weak versus a strong file format. Also, remember, it takes time to move data. So if we have something on-premise and we need to move it in the cloud, let's try zipping it up, right? It makes it smaller. Guess what? It copies faster. We'll talk about exploring file formats, and if we have time, which I can't guarantee, we'll talk about our DBMS, which is relational database sources, right? And I'll have to go ahead and turn on the capacity for that because I haven't spun up anything yet, but we could talk about that. But the main key learning objective is the file formats, and that's what we're going to focus on today. That's the first star. Double star is the bonus round. Okay, what is Spark? Well, regardless of where we're using Spark, say Databricks or Fabric, right, it has 4 components. First component built into Spark is data engineering. And how do we do data engineering? We read up some data, we manipulate it, and we write it back out. And that can be done 2 ways. We can use Spark SQL to do that, or we can use data frames, okay? Second thing is there's always machine learning, right? MLflow was acquired. It was a product that was acquired by Databricks, and it was open source. It's pretty much everywhere. So MLflow is in Fabric, okay? Streaming. Yes, there is no autoloader. That's a proprietary format in Delta Live tables. For both of those are proprietary for Databricks, but you can do structured streaming and you can do regular streaming from event hubs in Spark. And last but not least, there's always a graph component. You can do graph problems. So let's talk about Spark cluster. We don't have to really worry about this in Fabric too much because it's kind of obfuscated, but if you go into the cluster settings, you kind of need to know what it is, right? Most people are not even worrying about partitioning nowadays. They let the Spark engine do it, but at its core, somewhere behind the scenes, okay, you got this driver, which is a VM, virtual machine, and it's running a Java VMs, which means it's a Java virtual machine. And every node in here, you'll have some CPU. And so you have task 1, task 2, right? That's associated to that vCore, okay? So when in the past, we had to worry about partitioning. So if we look at this, when we ran a job, okay, we have 8 cores. If we had a file that was partitioned by 6, it could read up the full file and work on it, right? But if the partition was partitioned by 8, it would still work. 10, guess what? Now we would have to have 2 jobs, right? 2 main tasks, because the first task would, or a schedule would use 8, the second task would use 2, okay? So have an understanding of the driver, executors, and tasks is important. Not as important as it used to be. People are starting to use AI and move away from that. Okay, let's talk about a data hub. In the past, okay, we want always a loosely coupled design. That means that we have a source here, and again, S's are here. They can be either consumer or producer, right? So say we have SAP here. That's a producer, right? It has data. You can bring it into the hub. What could the hub be? In the past, we used to use just relational databases, right? That's what we had. Data lakes didn't catch on. But in early 2015 plus, right, data lakes have caught on. So this could be a data lake, right? What does loosely coupled mean? It means that I can take a component out and replace it. So if we copy over into raw and then refine, we change the data from SAP to be consistent to our model, guess what? If we move from SAP to Dynamics or vice versa, as long as we have that common model and keep to that format, it'll still work, right? And at the end, we have our consumers. It could be Power BI reporting over here. It could be machine learning, whatever you want to do. And again, if you keep this clean, you do data governance, you do data quality, it can be a single source of truth for the company, right? Okay. So this is Microsoft's design of the medallion architecture, right? We can see to the left, we have some data sources. And we already talked about files. That's what we're going to focus on today. okay? But we can talk to business apps as long as they have a REST API endpoint. Go look at the articles either on my SQL Server Central, or I did a bunch of them on my own LinkedIn. You definitely can call a REST API endpoint, usually get Java back, okay, JSON, right? And so we'll talk about the JSON format today. IoT, we talked about you can stream that, and databases is the bonus round, okay? And again, Medallion, it's just the quality, okay? There's a new thing in Fabric called Direct Lake. So as long as at the very end we have a Delta file format, means that any changes that happen in Go will directly go into the model, right? It's a analysis service model. It's the one we've been using for the last 15 years almost, right? When the tabular model came out. And also, regardless if you're using a lakehouse, you have a SQL endpoint, right? And you can put row level security, column level security, data masking on there. Okay, so let's talk about file types. What's weak and what's strong, right? A weak file format can lead to data quality problems, right? How many people have been woken up in the middle of the night and, suddenly find that there's an extra comma, right? Or someone put an extra quote and some text that you didn't strip it out. You got the file and ETL just suddenly broke. And it's an easy fix, but the problem is there's a lot of reasons why not to use CSV files. For instance, you can easily break them. There's no security. It's not binary, so I can open it up right away, right? There's no compression, right? So it can get quite big. Might not know what the data types are, right? Because it doesn't tell you, right? It's not like PARQUET, which you know what the data type is. So if you got an SSN, right, social security number, you might have something that looks like an alpha, but maybe we got Canadian social security numbers and maybe there's an numeric in it. So it should be alphanumeric, but we guess that alpha. That's what, Excel does. It has to infer the schema, so it has to read the whole file up to understand it, right? So those are a ton of reasons why not to use weak file format. Strong type, just the opposite. It fixes all those problems, right? So Apache file, binary, so you can't break it. And has the columns and names and data types. You don't have to worry about it. It can be compressed and it can be also partitioned. Okay, so let's start with our very first file format we're going to explore today, okay? Basically, like I said, this is not new stuff, right? At the heart, okay, we're using Azure Data Lake Storage Gen 2, even in Fabric, okay? And the thing is, we could use a no-code solution to zip up files, right? We can manually update stuff into the Lakehouse using either the Lakehouse Explorer or the GUI, right? And data pipelines can use binary copy to move the data in also, okay? So let's look at the file format. And again, I am not an expert at all these. I'm just an end user. If you want to learn more, you can spend lots of times figuring out all the compression schemes and algorithms that Zip has to offer. But the main thing is a central directory right here. It's at the bottom, right? And we can see there's pointers to file 1, file 2, and file 3. And then we can see for file 1, there's a local header. There's some encryption of the header, and then it's the data that's encrypted. And there could be local header 2 for file header 2, and so on in file 3, okay? So let's get into the demo. And I'm going to quickly see if there's any questions. I'm in the chat. There's going to put questions here. So if you have any questions, any comments, put them there. I'll answer them when I take a break, okay? So we're going to go to Fabric, and we can see this is our Lakehouse. See, it says Lakehouse, and it has 2 endpoints. It has first the endpoint for the SQL analytics, okay? And if we go into here and hit view details, if I remember right, we have a connection string. We can copy this, right? And who am I in? John, so let's see. And I'm going a little off script here, so bear with me. Hopefully I don't break it. Why did I do that? I want SQL Server Management Studio. There we go. It's an old version too, you can see. But I just want to tell you that if it's in Lakehouse, not only can you use it in the Lakehouse using Power BI and all those fun tools, but you can just paste it here, right? And now we can say, oh yeah, we're gonna do MFA. I'm gonna do John at craftydba.com. I'm gonna, whoops, need a com. I need to connect to it. And because it's highly secured, we're gonna go through a two-factor authorization. So authorization, and then we click it. So because I was already signed on, it loves me and I'm in. So now where was I going? Right here. And now we can see there's databases. We can see the file types. We go to tables and we can see tables. And I guess I didn't expose anything, but if we did expose something, it would be here and we can try doing that. Okay. So enough about the endpoints, right? I'm going to go back to, let's get out of here. Here's our workspace. And now we're going to the very first one, okay? So like any demo, when you have these notebooks, there's several different types. If we look at the notebooks, traditionally, when it first came out, we had basically these notebooks, right? We had a Python notebook. I like Python. Scala, if you like the object-oriented. Spark, if you're just doing SQL. If you're R guy, go R, right? Recently, they added a 2 at the bottom, right? A Python notebook, so it's less costly because Python, you don't need a whole cluster, okay? And we also have T-SQL, right? So you can do SQL Server, right? Syntax for the warehouse. And we also usually, when it first came out, there was only a Lakehouse. Now you can pick which one because this could be a SQL Server T-SQL notebook, okay? So now I'm clicking on it. We see there's a bunch of data here, right? And the problem is, well, you know what? I might not want to go ahead and drop it, right? So we can see that there's sales LT data there. We can see there's also, um, you know, SQL Server, there's all text. So I'm just going to clean everything up. We're going to clean everything up. So it's going to say, do not drop metadata table. And I don't even think there's a metadata table here because it's not a metadata design. So let's run this. So it says, get me a list of tables for each table. If it's not metadata, don't drop. If not, first I'm going to drop it. If it's not a view, I'm going to do that. I'm going to say if table, um, want to, do these have data? These do, right? So I'm probably going to keep the SQL Server ones around just for the heck of it. So I'm going a little off. I think this is it. Contains, and then, okay. I'm just going to go a little off track here just to make sure I don't blow everything away that I don't want to blow. And then we'll get right back on track. So I'm going to say print I, whatever. Just want to make sure that this SQL SVR. Again, this is always fun trying to do this in a demo, but I just want to make sure that I don't drop the SQL Server ones, that's all. So this is going to go through and it's going to say print do not drop this table, I hope. Right now it's spinning up a cluster, okay? So it spun up a standard session. I purposely spun up the standard session to show what they are and why not to use them, okay? This should run pretty quick. I don't know why it's maybe the cluster's sleepy. Mm. Oh. And again, I even myself go ahead and look at it. So we just want we can use the text.find, say. And again, there's just too many languages out there. And says if not equal to -1, then contains it. Otherwise does not contain, right? So let's put this in here, see if this works, and then we'll run the thing and delete all the tables except for the ones I want, right? So run it. There we go. So it said, hey, do not drop table, otherwise Hide's going to drop these tables, okay? So now I got my code. Sorry, I had to do a little Googling to figure it out because I don't do Python all the time. And so if do not drop the SQL server and then tables. Okay, so it's going to say if it's not equal to -1, then it does here. Otherwise, it's just going to drop these, right? Going to run it. And now when we go here, we should have it. See, it's dropping these. So now if I hit refresh, we're going to have a nice clean, see, cleaning it up for us, okay? Then we're going to do all the demos. Awesome. So now we have a clean place to start. I'm going to get rid of this temp code, trash it. Okay, cool. So let's talk about zip files, okay? I organized this really easy for you. So this first one basically, so here's the thing. I stopped it. I said, don't close. Oops, is that good? No, it isn't, because guess what? When we open up a cluster and we don't stop it, right? It says it's still in process, right? So what we want to do is we want to cancel this, right? So that's actually going to stop our compute. Remember, we only have 64 cores. If we do not use a, what they call it, concurrent cluster, high concurrency cluster, that basically it's going to keep on running. And we don't want that because we only have so much. So it says in progress and a view detail. And we can see hopefully submitted, but status is running. It should be canceling it. Yes, stop. Okay, I'll come back to that if it didn't cancel it. So our very first one is manage zip files, okay? So we're gonna go to the Lakehouse, and first thing it says, hey, look at Lakehouse default file stock, all stock data, CSV and PARQUET. Okay, so let's see where that is. So it's gonna be Lakehouse files. So remember, in the Lakehouse, there's two main directories, okay? If you look through Storage Explorer, you're gonna see a /tables/files, okay? We can also see that I deleted everything except for the delta tables, okay? And we can see the delta underneath being a delta table for this data from SQL Server. And this is your SQL Server, basically EventWorks, okay? So, or Sales LT, which is EventWorks. So now we see that it's in the stocks directory, okay? In the stocks directory, we have the zip file and the CSV file. So these are quite huge. And again, I might multitask and go to the next slide and let this uncompress and then come back and finish it. We'll talk about it. So this is now done, okay? I removed one at least, it's still running. Maybe it removes the second one. I'll minimize this. And so we can see it finished, okay? So if we go to Lakehouse, don't know why I got rid of that, but stocks, and we hit refresh. Where's the refresh button here? Nope. Okay. So let's do this. We're going to say path equals this, and we're going to do a list of it, right? We want to see if there's any files there. And now there's only one file. We can see that this is quite big, okay? It's like a gigabyte file, okay? So what we're going to do now is we're going to unzip it. That is very easy to do. There's a library called zip file. I'm going to say import it as Z. Here's the path to the stock. Here's the archive file. And again, we can try getting back this because I've had problems with this. So let's hit refresh. There we go. The archive file's there. One of the things I'd like to do, which I don't see, is there's no properties here. You can't tell how big things are. You have to kind of use this, query it, and then you see a size, and this is in bytes, and then you have to use a calculator, right? So we're going to import the library. We're going to set the path. We're going to add to the path the file name. With the path, we're going to say extract all. So it's going to extract anything that's there, okay? If I remember right, this took a couple minutes. So while that is going, we're going to go back and talk about delimited files, and then we'll come back to the demos. That's the only one I remember that's really, really large. So what is a delimited file? Well, each row of data is ended by a carriage return in a line feed in Windows, or it could be just a line feed in Unix. I forget which one it is, but it's only one, right? The header for this is optional. We talked about that, so you don't know what it is. Regardless, you should probably define a custom schema so we don't have to infer it, right? There's some shortcut notation. We'll talk about that. Cut notation is really cool because you can use it when you select, when you're using Spark SQL, okay? And in Spark Read, you can also use many different options such as string quoting, delimiter, the header. You don't get that when you use the shortcut, and I'll show you how to get around that. And please note, only managed tables can be used in the analytic endpoint. So if anything's unmanaged, it's not going to show up there, okay? So I think I did a good coverage of delimited files, which are just basically text files. You've probably seen comma delimited, there's pipe delimited. You can use any type of delimiter character, okay? So we kick this off. Oh, well, guess what? The demo might go fast because I'm working with an F64 today. So, okay, so look, boom, everything's uncompressed. That's awesome, right? One of the things you want to know is that there's something called mounts, okay? And in a mount, okay, there's always the default mount. And remember I said it was in blob storage, and lo and behold, it's OneLake.df, so it's data lake file system dot fabric. And this very first one, if I remember right, I might get them backwards. One's the workspace and one's the lakehouse, okay? And that's what those GUIDs are. And then at the very end, that's it. And there's a notebook directory, okay? So those are your mounts. They're automatically there. So let's talk about zipping it up. And this is the harder part to do, okay? So we want to get a file listing, right? We want to list it, get a listing, and we also want to filter it, right? So this is a little utility function that we need, okay? So for instance, if I say, get me a list of files that are Microsoft, I can see I have 5 years worth of CSV data for stocks, okay? These are Microsoft stocks, okay, cool. What happened in the, open, close, average close, whatever, for stock files. Okay. We also need to find a function to unzip it up. And the reason why is that this zip file function does not understand the distributed storage layer here. It will work if you're local, but if you're using distributed, you have to do something funky. So what we're going to do is we're going to say zip up files. First, we're going to take a folder and say, hey, this is the folder. Okay. We also need a path too, which would be the lakehouse files. Okay. We also want to just pick the pattern. So maybe just CSV files. So first we're going to get a list. Then what we're going to do is, because it doesn't support writing and appending to the storage, it only supports one-time writes to the storage, which is basically a REST API call, right? We have to make a buffer in memory and then write it out, okay? So this was going to use a zip buffer from the IO, okay? And then what we're going to do is, with the IO buffer, instead of writing to storage right away, we're going to write to memory. And then afterwards, we're going to open up a write and write to storage, okay? So this is another function that we're going to write, okay? And because the first function was get list, and that's used by this function, which is called zip up files. And then what we're going to do is we're going to say zip up files in the Microsoft directory. So if we look here, okay, and we're going to call it archive2. Now I can see archive2 already, exist there. So I'm going to get rid of it. And what we're going to do is we're just going to run this. And now if we hit refresh, hello. Okay, refresh. And there's archive2. Okay, so I am going to go a little off track here. I tried this before. Hopefully it works, because I want to show you all the tools that you can use when dealing with Fabric. Let's see if this works. If it doesn't work right away, I'm not going to spend too much time on it. Okay, so we can do storage account. That's not what I want. This guy. Yeah. He's not the pay-as-you-go. Come on. Storage accounts attached. Web containers. Okay, this is it. Come on, please. Okay. Okay. Why don't we go back to this? But one of the things I want to do is download the zip and show you that it worked. So if we have time at the end, I will do that. Let's get back to the next demo. Always, if it's a standard session, stop your session, okay? And now this will stop, and I'm going to close it. And now if we go to monitor, we should see that the other one stopped, and guess what's in progress? And it's in progress because it's shutting down, okay? So the second one we talked about is managing CSV files, right? So we have a simple demo here. We're going to click Lakehouse. We see the same tables, right? We haven't posted anything. We just played with zips, right? This time we're going to talk about reading files and going ahead and making tables, okay? Because that's those managed tables, the only thing that it really likes, okay? So we're going to select star from CSV that all stocks. We're going to get 5 of them. Hopefully with the F64 it goes pretty quick because these are big files, like I said. And guess what? Oh man, CSV works, but look at this. It gave me a standard, it doesn't understand that the first line's header, okay? So I kind of need to remove this, and I kind of need to rename underscore C0 through C8, okay? So we got some problems there, okay? Let's do spark.read, okay, without a schema, and let's see what happens, right? And then let's print the schema, and guess what? We didn't give it, again, this is a CSV, so it does the same problem, right? Okay. Well, how can we fix the first problem? The first problem is we can use a CTAS, right? Create table as. Okay. And what we're going to do is we're going to drop the existing CSV dot example1 from here, and then we're going to cast everything because everything's coming in a string. See, these are all strings, so I'm going to cast it to the right value. Going to use that C, and I can limit it, but I don't need to because I got an F64 now. So let's run this. Might take a minute. Now, once this is complete, we want to actually take a look at the details, right? And one of the things we can do is I'm going to skip over doing this demo, but I'll show you what the output is. Describe table extended. What does that do? It tells us the data types for one thing, so we can see all the data types, but it also tells us information of where it's stored. So now we can see that's actually stored in this location under table CSV extended. It's a Delta file format and it's managed. So this is good because we can put it in the endpoint, the managed ones, okay? And this is still running. Like I said, it's going to be running. We can also select, say, the first 5 of them, right? We can see that now under like before, which was string, we can see at the top, see the icons? This is a date. The 1, 2, 3 is a string. 1, 2, oh, I meant numbers, right? 1, 2, 3, 1, 2, 3, A, B, C. That's a string. 1 dot period 2, that's a float. See, we got our floats in, and that's it. So everything works fine, right? So let's see, it's coming up. Did it read it? It's still reading. Wow, even when F16. Oh, it's 64. Okay, so let's talk about the second one, and we'll run this one. So we can drop the table, second one. We say create table if not exists using CSV. Using CSV. Well, that means that it's not a Delta file format, and if it's not a Delta file format, it's going to be a unmanaged table, which is not what we want, right? And so let's see. Wow, it's still running. We can see all the jobs if you're curious about the Spark information of what's going on. Okay. So let's talk about the metadata. So if we run this using create using, well, this should go really quick because we're not reading up the whole file and we're not having to read the CSV and create a Delta file, okay? So it should be quick, the select should be quick, and if we do this again, we're gonna see that this is actually, oops, a unmanaged, it's gonna say external somewhere, external right there, okay? So let's go back, see if this is done yet. Wow, 2 minutes, that took a long time, right? So we can run this again, this will take seconds. So we can see it's managed. I wasn't lying about it. I don't know why this says diagnostics. It should just run. Boom. And if we hit here, we hit refresh, we get our first managed table. Okay. Now we're going to create unmanaged table. I don't know why this is, there we go. So this is the one that was unmanaged. This should be pretty quick because we're not really doing anything other than reading up the values. Come on, maybe I'm talking wrong. Let me check while this is going. Is there any questions? I don't see any questions. Cool. Okay, so at this point, it's still running. Shouldn't take this long. See, create table if not exists using CSV. This should be just metadata. So I don't know why it's reading the whole thing up, but maybe because it's star.csv, there's a bunch of them. And then what we can do is we can select from it. And so there's our stocks, right? Okay. We can also do the metadata. Okay. Okay. So let's try doing this again. Can we refine this to be better? Yes, we can. We can go ahead and do all stock data, which we know is huge, and then we can give it a custom schema. See, this is custom schema, and then we're going to give all the options for the read, okay? This is the most flexibility in to use, right? We can tell it's a CSV, we can change a separator, we can tell it's a header, we can firm it, we can give it a custom schema, and we can also, if you do save as, we're taking the data frame that we read in and save it as a CSV. So this is going to run hopefully faster than the 3 minutes. And then at the very end, we should run a rec account. They should all match, okay? So that might take another minute. So I'm going to go to the next slide, talk about the next table. And then the rest of them should be pretty quick. I just apologize. The very first one's a lot of data. So text files. Well, when do you use text files? Well, I use text files when you have something that's not really structured. It might be semi-structured or unstructured, right? You're just looking for that needle in the haystack, right? So how can we extract the data from the file by parsing each row? That's what we're going to do. During parsing, we basically want to throw out the unwanted rows. Rows that have interesting data are saved for consumption, right? So if we go ahead and get rid of this and we take a look, we can see that this is a NASA log file, okay, from 1995. It's old data. But we can also see, oh, a 304. A 304 is an error, right? I want to see all the errors, right? That might be something that I'm interested in. So in this next example, we're going to work with text files. It's going to be basically a log file from an ISS server or Apache server maybe. And it has the URLs, it has the get a post, and it has the status code. And we just want to find ones that had errors, okay? So that's the whole example for number 2 for text files. And again, text files is the default format when you cannot parse it with anything else. Okay, so this finished. Wow, it's still running. Okay, let's see. That one's running. Let's see if I can maybe open up another notebook. We'll see. Haven't tried this yet. Should be able to. Going to talk about text files, right? Got a Lakehouse. Okay. So now what we're going to do is we're going to connect. I'm going to do a new high concurrency session so I don't have to keep on closing them down. Okay. And this one will stay up and we can just close it and then we can reuse it till we terminate. Okay, it's up. So now what we're going to do is drop the table. And again, we can say create table if not exist. We're going to use the shortcut. See, it's text. And then look, it's that backtick. Okay, the backtick gives you file location. Okay, and we're going to use the Spark notation. We know everything's rooted in files, at least in Fabric Lakehouse /NASA, which is here. And under the NASA files, we can see there's the log file, right? So it's going to basically create a table if it not exists from that file, okay? And so it's almost done. Okay, now we're going to get some table information. We can take a look. Okay, well, guess what? It's a managed file. It's Delta, okay? And so we can create unmanaged. We can say using text, right? Same syntax, but a little different, right? And we can describe extended. And again, remember, external files or unmanaged cannot be in a SQL endpoint. That's the only way you can share data to Power BI or any end users, okay? If we select the top 5 rows, from the first example, which is a Delta file. I want to go fast. I don't want to read from CSV. We can see we got this gobbledygook. We have some dividers and stuff like pipe and then a pipe and then pipe. So we want to kind of parse on pipes, right? So there's a function called split part, and you can say, okay, this is value. Given split part on the pipe, I want the third one, and I want to do some replacements, and I want the URL, and I want the response. So I'm splitting and picking the third item, the fifth item, the sixth item, and then I say where the row number is greater than 1. So because I don't want the header, if there's any headers, I don't know why RN is here. Row number order by. Maybe because it was a header value, but I don't see the header there, but we'll leave it anyways. And it's not equal to 10, and just show me the 10 errors I have, right? Yeah. Voila. And there we go. So we can see some errors now. We can see the row number, and we can get the method. So we're doing a get on some type of image with a query parameter, and we had a 302, and this is the response time, okay? So wow, we can definitely parse text files. We could do in-string or pattern match in here with regex, whatever you feel like doing, okay? Let's go back to, let's hit no. Oops, I hit the wrong one. Stop and close, sure, why not? Let's go back to this guy. I hope he didn't close him. This guy was still running, right? So let's see if we finished. We can check that out by hitting a refresh button here, right? And we can see now we have all 3 CSVs, awesome, and we can see the record counts totally matched, right? And we have our 2 TXTs, okay? So now we can stop this standard session, right? We always want to clean up. If we don't, we can go to monitor. We can see these are all shutting down, so awesome. So let's talk about the next file format. Okay. This is one that you're probably going to use all the time when you're working with REST APIs. It's called JSON, JavaScript Object Notation, okay? What's nice, it's human readable, okay? So you got names, but again, there's only a limited amount of data points, right? And just like any text format, there's no compression. There's tons of bloat because now, because we're prefixing everything with a column name, okay, and colons and parentheses, we get a lot of extra bloat, okay? So let's work at the JSON files. Then go back to my examples here, and we're gonna explore JSON files. Okay. So there is some earthquake data I got from the USGS, okay? And if we look at it, we can see earthquake.json, okay? Drop the table exists, and we're going to select from JSON, right? Create table if not exists. So this is going to be a managed table. Anytime you see create table or save as table, that means managed. Anytime you see using, that's unmanaged. Okay, so now it's done. We can describe it, and we can see it's managed. Okay, great. Now what we can do is the problem is that I'm gonna go a little off track here and just do a percent SQL because I want to show you the problem before we solve it. Let's do select star from JSON dot one. Okay, there's no such thing as a couple things. First is I'm always thinking Databricks, so you need a double equals. Second thing is there's no top, so we need a limit. Okay, so now once we get our syntax right, guess what? I'm going to show you what the data looks like. Then I'll show you why we're doing this. So we got this geometry point, but look, it's basically a nested schema of JSON. Also, we have properties. It's all nested stuff, right? So for us to get the type, we have to do properties dot whatever the type is, right? and so on. So you always want to use the dot notation. So we're going to do dot notation. We're also going to take the time divided by thousands from Unix to get a timestamp. And then we're going to grab the first 50 rows where the ID is not equal to null. Okay, so now we actually have some data. We got an ID. We can see the coordinates of where the earthquake, the magnitude of the earthquake, the place. Hey, that was saying Hawaii, Alaska. I see a lot. Alaska, Taiwan. A lot of ring of fire going on here, right? South Pacific, I see. Right, but then Costa Rica, well, that's in our side, right? East. Where else? Taiwan, yeah. So those are top 50. Interesting. Okay. How do we deal with JSON? Because this could be quite complicated, and I always have problems dealing with it, right? You know, in Spark, there's a little function out there most people don't know, and I'm going to show you. So it's something called select schema of JSON. So if we cut and paste that schema, and I just got one record, it's going to come back with something that looks like a struct that you can use, okay? So we see it here. Cool. But this is not really a struct, okay? To really convert in struct, we need some code. So we're going to do spark.types. We're going to take the struct from the select that we did of a sample, and we're going to say, hey, convert it into basically a struct, which is Python for describing this. And now we have this complex nested struct, okay? And guess what? Now I can use that struct, okay, right here. We're going to do custom schema. Well, we printed a custom schema. We're going to use it. And now we're going to bring up this and we're going to create replace a view. So now I'm going to be able to query it, okay? And why did it not like me? Path 2 not defined. I must have skipped something. Or let's look. D1, path 1. Oh, I don't understand. Must have did some adjustments to this. Let's run again. There we go. And now what we can do is we can look at which one is this doing? Hang on a second. Explode. Okay, so at this point, what we can do, and I haven't showcased, I should have showcased it, is that we can just do select star from TMP underscore earthquake. Get this right. TMP. Let's just double click this. Now I know I got it right. Oops, come on, making it bigger. There we go. So this one took a data frame and just in memory made a temporary table. Once you kill the Spark session, that temporary table goes away, okay? And there we go. So now we read in the data, but we still have to parse it, right? We still have those dot notations, okay? This one will take the CTE, which is temp earthquakes. Okay, so I was using it then. Just not looking. And what we're going to do is we're going to explode on features, and then we're just going to CT it. And guess what? We get the same data. Okay. Now what we can do is, since we have that, we can productionalize it to say, hey, guess what scheme is? If we needed some format, we could do F in front of it and put whatever in curly brackets here. But basically, we're going to spark.sql run statement and then save it as a third example of a JSON. Okay. And because of the save as again, this is going to be a managed table. Keep on doing managed tables. So now we describe the extended, it's managed, and guess what? We can also do create using JSON, right? That's the last syntax. And if we look at it, we're going to get external because it's external. And last but not least, we're just going to say, hey, we got all these tables. Let's make sure the record counts are the same. And while that's happening, see, this doesn't refresh all the time. You just know how to hit the refresh. And voila, now we have some JSON examples here, okay? So the main thing with JSON is to understand that you need a schema or explode. And I suggest using the schema because it doesn't have to infer stuff at runtime. You're giving it a very explicit one. So next thing we're going to talk is the precursor to Delta, which is Parquet, okay? And we're going to go to the slide deck and talk about Parquet. I'll talk about two of them and then do two demos in a row. I'm also going to quickly take a look to see if there's any questions. Yes, everything that's here, just Google GitHub John Miner 3, and you'll find everything I'm talking about here. It's called Understanding File Formats. So all the stuff's there. And it's all data sets I got off the web. So, and I've given rights or references to them because obviously that's important. I don't steal content. Okay, Apache file format. What is Apache file format? It's a binary format, okay? And the interesting thing is it's doing column storage, right? So instead of being row-based like CSV, data store is column chunks. So we can see that we got the file and then there's pages, and the pages, you know what, it has a bunch of offsets and compressed, uncompressed size and metadata. Footer, again, I am not an expert at the internals of Apache Parquet. Most people are not. The thing is, it lends itself pretty well to compression. Remember I gave you a bunch of links? One of the links I showed in there was exploring file formats with Databricks, okay? And it was from MS SQL Tips. Go take a look. It shows a comparison of sizes versus runtimes when using some moderately sized files, and you can make your decision. That's why Microsoft / really Databricks came up with the Delta file on Parquet, because it's a middle road compression. It's column star, and it was nice, right? So Apache file format's one we're going to talk about. Next one after that, maybe I'll do three in a row because they're all similar. These next three are all basically Apache file formats, and there's the one called AVRO, okay? And AVRO was designed for deserialization of RPC, remote procedure calls, RPCs, okay? So if you're doing programming, C#, it was there. And what's interesting is that the metadata, unlike before, is actually a JSON block, okay? And the contents are stored in row fashion. So we can see the AVRO, we have a header, and the header, basically it's some type of metadata here. See, it's in JSON format. But then the blocks, we have count of blocks and size of blocks, and it's serializable. So it has to be something that could be sent over the wires, right, and uncompressed, okay? Org files. Org files is interesting. It's another column store, okay? And basically, it was basically designed to fix Hadoop's RC file format, okay? Supports a variety of compression. A lot of these do. Like, you know, you can do Parquet and then Snappy, right? It also allows you to do predicate pushdowns, because now we have basically stripes of this, and if we were only doing certain columns, right, we could do a predicate pushdown, or maybe a certain block, right? Lightweight index to keep track of min max. So that kind of like, if you know the min max for a particular column, you can start doing basically skipping partitions, right? Or skipping blocks, right? And that's why predicate pushdowns are really popular. Okay, so we're going to do three in a row. They're all Apache file formats. Once we get past that, we'll talk about the Delta. Okay, so Parquet format, right? Again, we're going to create if not exist Parquet, and what I'm going to do is I'm going to do some casting. I don't have to, but I want to take date and underscore it because date's a reserved word. I don't like reserved words, okay? Also, I'm going to create some new data. I'm going to create year and month, right? And then I'm going to say, hey, stock splits as stock splits, because there's a space, it doesn't like it, right? And now we're going to basically say create table if not exists. So that's going to create us a what? Managed table. Anything that says create table is managed table. Hopefully this doesn't take too long. It's Parquet, so it shouldn't be bad. It is a big file though. While that's going on, I'll go through the next sample so we can select top from that. And we see there's some data here. Okay, that looks pretty good. We can also describe, and we can see it's a managed table, okay? Another way to do this is we can create a unmanaged table using the using command again. Anything using means unmanaged. Let's see if this is complete. It's still running. 09. This is kind of like watching paint dry. If you poke at it, it might not run as fast as you think it is, but eventually it'll get there. This unmanaged table will just create using SQL, so hopefully it just puts in metadata in. Again, if we select from it, oh, interesting, we get external file format, and then we do some sample records. We have something that's similar. Last but not least, we can manage the two, and we should get the same row count, and we did. Right? So let's see if this is still finishing. Okay, so it finished. So now we can run this. We can see the top 10. And again, this is repetitive because we're trying to show you different ways to either create table as using shortcut notation. These questions, even on exam, I've been helping people at work study for the Databricks exam, and they might see these questions there. So this one's going to drop Parquet second one. So I'm going to hit refresh and rebuild it. And wow, look at that. Because it's ready in a Parquet format, it just 3 seconds, it's done, right? That's kind of cool. And then we describe it, and it's there. And last but not least, we can select the top 10. It's going to show it, and then we'll run the managed. And so we can run these two, and that's it. So the next two formats I'm going to show you are kind of edge cases. You're probably not going to see them in the wild too much. Okay. I had to actually make the data for them. Okay. So see, this is make Apache files. We're just going to, hopefully they're there already. Let's see where I'm pulling them from. If not, I'll have to run that, but files, stocks, so let's go to Lakehouse, right? Files, stocks. Okay. Create table if not exist. As selects from AVRO stocks, all stock. Okay, so the problem is I do not have the data there, right? So I'm going to have to run number 6, unfortunately. Okay, so basically, this is the function to find files. This is a function to unclean up files. When you write a file out, basically it sticks in the main directory, and then what we have to do is bring it up. So what we're going to do is any of these data splits, AVRO does not like, so we're going to basically create the same thing. We're going to overwrite, we're going to make an AVRO, going to unclean it, we'll just get a single file versus the parts of it. We're going to redo this for orc, right? So if we look down here, orc overwrite, clean it up, and then we just review file sizes. And so we can see that the AVRO, this is probably in gigabytes, is 1.24. Orc's the best one, and Parquet, well, Parquet is the best one in this one. And then CSV, you can see it's a 3 gig file, okay? And the zip file is 1.9 gig. So let's run all these. We'll create some data. Let's go to slide deck because it's going to take a little time. Okay. Okay, Delta file format. So why is the Delta file format really important? I have a fellow friend, Brian Kaflicki. He's used to be an MVP, has his own YouTube channel. We're still good friends. And when he came to me, and I was working at Microsoft at the time, and he went to work for Microsoft after I left, he said, you know, this is like sliced bread, man. It's going to change everything. And it really has, right? Why is Delta file format important? Because it has those ACID properties of a database. Okay, so atomic, consistent, independent, and durable, right? You can also in schema enforcement, so allows only cleaner data to be. So if you add a new row or a new column, it'll throw it out. Time travel, right? Because you're using every time you make a change, insert, update, or delete, you get a new Parquet file with a log file. You can go back in time as long as you don't vacuum and optimize, okay? Snapshot isolation. Well, multiple readers can definitely read. Writers, well, they can be blocking what writing. This whole article on MS SQL Server Central you should take a look at. Yes, it's open source format. It's built for distributed systems, okay? And then the last thing, if we get to it, is relational databases, right? And when you use a relational database, you want to put secrets in a key vault. We can do that, talk about that. And then we have to install a driver, right? Remember, most of these functions use data frames. And what does the data frame mean? It means you read up a whole table into a data frame. When you save a data frame, you write a whole table of data frame, okay? And you can use a metadata driven design to move like the pub stable to the lake. That's one way. If you want not to read and write the whole thing, you can, but you'll have to use something like PyODBC, and then you really don't need Spark. You could probably use that Python notebook, okay? And then we'll talk about the summary. So let's see if our data files are done. Okay, it's still doing the orc one, but it created orc. Okay, and if we take a look at the lake house before we see it, hopefully we can catch it. We can see, didn't refresh, come on, refresh. Hopefully we can catch it before it goes away. We can see that, okay, it made a subdirectory, and in the subdirectory, this cleanup one wanted gets rid of everything except for the orc file, brings it up, and now we have an orc file in a AVRO file that matched the Parquet, okay? So our demo's all set to go. So let's do the last two formats and then, or three. So we got Parquet we did, AVRO's next, Orc and Delta. So we can again create table. We're using the shortcut if not exists, so we're going to run that. This is going to take it out of the AVRO and put it into the Delta, so it might take some time. So we had to stop the news cluster. While it's running, let's see if there's anything extra running. So not in progress, right? So this one should be closed. And that should be stopping that. So it should be stopped. Okay, cool. Let's go to AVRO. Okay. Joseph, do we have a few minutes to do the Python demo? I meant the Postgres demo, or you think we're out of time?
Yes, that's fine. Feel free.
Okay.
I can spend up to 5 minutes.
Okay, let's see if we can start it. So what we're going to do is while we're waiting for that, because we're just bored anyways, right? We're going to go to all resources, right? So we're going to find all resources, and then hopefully this is ready to go because I teach a lot. Hopefully I didn't break it. That's what happens when you have a lot of demos. And what we're going to do is we're going to type equals to, and we're just going to look for, there's many different types, but we have the flexible Postgres, okay? So we're going to do that one, hit apply. These are expensive. Use logic apps. I have a whole article on how to use logic apps to turn stuff off. It automatically gets turned on once a week for backups, which is kind of crazy. So I get charged for some during that. So we can see it stopped right now. So we're going to start the Postgres server, okay? Cool. And this one, is it still, did it finish? It looked like it finished. Okay, a minute. So now we can run it. We can see there's 10 records. We'll pop those out. Same thing we've been talking about, stock data, right? It's a common theme here. So we can see our stock data. We also created 2 calculated columns. Okay, great. We can get information. See it's managed. Let's try an unmanaged. So if not exists, use an unmanaged. So it's just going to put a metadata on top of the AVRO file. That's all it's doing. And now we can go ahead and say, okay, describe it. And it's pretty quick. And it says it's external. Show top 10 records. And guess what? We see some records. And guess what? We can run and compare the two. And we should get the same count, which is like 300 or something. I want to say 3 million, but we'll see. It's been a while since I looked at the data. So we're looking at what? 34.6 million rows, right? And it matches exactly. Okay. So our demo worked. I'm going to stop and close. I'm going to bring up the org files. And then we'll go ahead and again, we have to connect. I'm going to do a new high concurrency session. So that way I don't have to keep on starting these. Gonna get a couple more demos. So I have to remember it's there. Okay, so now it's there. So now we can, this is wrong. This is supposed to be orc. This one might take a while. It took 1 minute and 42 seconds last time.
While you're waiting, you have a couple questions. Would you like to take a
Awesome.
look?
Yeah, I'll definitely take a look. Okay, so one question was, how can you just look at 10 rows of data? Let me give you an answer. There is an extension for VS Code. That's one way. You can also just do, like I said, select star from like PARQUET dot, and then the ticks, right, the path, and then you can just do limit 10. That will also get you the top 10 rows if in there. But if you had downloaded the file, right, you can use the extension for VS Code, right? And I've used it before. It works really good. So VS Code extension for PARQUET. And there you go. There's a bunch of them. It's PARQUET installer. There's PARQUET viewer. I don't know what the difference is. You can play with the two, but there is, don't know. Look at the download numbers, right? Because I wonder if there is, say, made this one. Yeah, these are both from powered by DuckDB. So I would take a look, but this one looks pretty decent. He's doing basically the Iris Parquet, and he's doing a select query from it. Isn't that cool? So I would definitely take a look at this one. Second question, why we have to define one by one types and names of the columns to create a managed table on DBX loading from Parquet. I did that because I was actually going ahead and, if I remember right, changing some fields. That's the only reason why we had to do it. Otherwise, you can just definitely go ahead and bring it in without doing that. I thought I was adding some extra metadata. Let me double check on that one. Boom. Okay, so let's go back to that one on past this. So delete it. We're going to show it again, right? And again, see these file formats that strongly typed, we're not even telling it anything about fields, right? You just bring them right in like you just suggested, right? And we describe them. That's why you want to use strongly typed files. And then we can drop it. This is external, right? We're going to use it, not create a new table. Okay, and now we can do the same thing. We'll get external list, external. And then we'll select the top 10. We'll get some 10 rows. We compare the row count. I'm going to skip this part and we get the same answer, okay? So this one's still running. I'll wait until this is done and then perfect. Now I'm going to close this. Do you want to stop hitting no? Because I'm going to reuse the live session. I'm trying to go faster. So hopefully the live session's there. So we can just click to it, say it's there. So this one's Delta files. I didn't realize I did not go back and fix these. So what we're going to do is we're going to bring in the Fisher data set. It's interesting that he did it. And we're going to use pandas to read it, just for the heck of it, right? So now we have the pandas and we're basically going to do a head. So there's pandas, okay? I'm going to drop the table. We're going to create a table and we're going to show an empty table. So we're just going to create in Databricks an empty table. Okay, or not Databricks, but Fabric. I do a lot of Databricks demos too, so I apologize for getting it wrong. It's all Spark though. So now we can see there's our AVROs, there's our orcs, right? We just did Delta right there, just created one, right? And it's blanked, right? There's nothing in it, okay? We can describe the history, and history is really good for that time travel, right? And we can see that basically it's just a crate, there's no inserts, right? Now, what we can do is I'm going to show you something that you should not do. And this is the reason why I'm doing this, is just to show you what's wrong. This is going to create a function called process row. It's going to insert into that row one by one, and it's going to run and it's going to apply it. Okay, so it's going to run each time. Okay, this is what we call R bar, row by agonizing row. And it even gets worse because in here, this is going to take 3 minutes to run. It gets worse because row by agonizing row, it has to create a Delta file. and a JSON file for each one of these. And so when we did this right here, version 1, we're going to have version 151, right? 150. This is zero based, right? It's 151s. And what it's doing is if we could get another one, again, it's probably going to cancel this. Maybe I can start another session. It'll basically show us that we have them growing, right? Unfortunately, this is 3 minutes, so let me see if I can get another window to show you that example. So click this, opening up another Fabric window, and then I will go ahead and log into 9, right? And now we can connect. I wonder if I can stale it. Maybe I can, we'll see. And now I want to run this. Let's see if it allows me to do this. Nah, Spark's not too, Delta's not too smart, or Fabric. I have this one here. It knows it's running over here, right? Oh, did it disconnect it? That is weird. Oh, maybe when I grabbed it, it disconnected it. Okay. Let's try this then. Let's do new standard session. Let's do this. It's not running here anymore. And now let's just run this guy. Nope, it doesn't. It's just really weird, Gene, because you know how in Databricks you can open up the same notebook and run it twice? This one's smart enough to know that, whoops, it's not running. But then it came back and said it was running here. Let's see if I can get it to work. Never tried this before. Now, see, I got a stand session, but it's saying it's running. Even though it's not really running, but it should be running in this window and not in the other window.
Yeah, I would suggest to stop.
Yeah, so let's get past
Yeah.
this one. The main thing is this, is that when you use the Delta file format, you do not want to do row by agonizing rows. This is going to take 3 minutes to run, okay? Last thing, let's end up, I'll just show you the notebook for reading. I'm going to let you explore on how to execute it, okay? We'll call it it. So main thing you want to do is when you use something like this, you need an environment, right? And the environment you selected isn't available in this workspace. So for some reason, it's not there. So I'd have to get this environment over the PG. But the second thing is not only that, when we use this, we want a key vault. So we have the URL, the username and password, right? And once we have that, and what we want to do is we want to actually just read. And this function right here says grab Postgres table, URL, password, and returns a table. Basically, it reads as JDBC, returns as a data frame, right? And then what we can do is we can make a utility that says, make Hive table, take a data frame, convert it to a table, drop table if it exists, create the table. And now guess what? We have a metadata driven design here. We have all the authors for pubs, okay? That's the source, that's the target. And then what we do is for each element, we can see the source and target. Perfect. And then last but not least, to put it together, for each element array, we grab it and then we write it. And basically it just writes all the tables here, okay? So let's finish up the class and that's it. So I'm sorry the last demo took too long. I'll have to maybe try to get a data set that's a little less bulky. Summary, Microsoft is a one-stop shop for all your data fabric and analytic needs, right? Basically, you get to pick your adventure. Could be a lakehouse, could be a data warehouse, machine learning, Custo database. Okay, I didn't show you Copilot, but I do have a F64, okay? I'm very cautious about it. I turn it off. If you run it, it's $8K a month. I only get not even that much more from a whole year from Microsoft to demo stuff as MVP. So after this, I'm going to disable Copilot and ramp it down. But, I keep on logging bugs. There's a bunch of bugs, but it's an awesome product overall, right? I hope that Microsoft listens to MVPs of all the bugs we've logged and gets them fixed. It'll make the product even better, right? Regardless, if you know SQL, you know Python, you know Spark, right? You can get work anywhere, right? You can work in Databricks, you can work in Fabric, you can work in Google. They have Glue. They're all sparked, right? And the future is basically bright for those to adapt. And Gene will probably tell you if you haven't done AI yet, you better start doing it because that's where everyone's going, right? Here's a bunch of links. Lakehouse notebooks, text format, CSV, JSON, AVRO, ORC, PARQUET, Delta. These in this whole column right here, I consider strong type. These over here, weak type. And the Postgres connector, you can also do it with stocks, which would be SQL connector. We have stock data, NASA data, earthquake data, Iris, and Pubs database. And thank you for your time. I'm going to stop sharing. I'm going to bring my camera on and answer any other questions.
What an amazing presentation. You always nailed it down, right?
Thank you, Gene. Thank you, Gene.
Great. And team, you do have access to unmute yourself if I'm not mistaken. Feel free to come off mute. Either thank you, John, for this wonderful presentation or ask question.
Thank you.
I don't think you left room for question though.
Just a minute or two.
No,
I always
no,
try to jam
no, I
everything
meant,
in.
John, I probably wrongly expressed myself. You did a great job. You didn't leave room for attendees to ask question because you well elaborate on each and every steps of the scripts. Great job, man.
Thank you,
On
man.
that. Mhm.
I appreciate it. And I can't wait till next time we bump into each other. It's been a while.
Yes. Which event are you going to?
Are you going to be in New
planning-
York City on
Yes,
May?
I'll be in
I
New
will.
York City. Yeah.
I think that will be the next time we'll see each other.
Yes.
Until then,
Yeah.
brother, you stay healthy and safe.
You too. Thank you. So, team, if you don't have any question, I will stop the recording. Thank you so much for joining us, and